The chapter is area related to circles for standard 10, and this is part 3. Now we will be doing some problems related to the minute hand and hour hand of a clock. So before we start the problems, we will discuss about the concept, the formulas that we are going to use here. So this is the hour hand or the short hand, and the long hand is the minute hand. And you know that the minute hand, that the long hand goes around one circle, that means 1 hour is completed, and the short hand, when it goes around one circle, 12 hours is completed. So 60 minutes, first we will do the minute hand. So the minute hand in 60 minutes, that is, it starts here and the full rotation it goes, so that it will complete 60 minutes, it will complete one circle. So that is, one circle is 360 degrees. So 60 minutes is equal to 360 degrees. So 1 minute is equal to 360 by 60 is equal to 6 degrees. So angle described by minute hand in 1 minute is equal to 6 degrees. So this is the value that we will be using in our problems. And similarly in our hand, when it goes one full circle, that is 360 degrees, it will complete 12 hours. In one circle, it will complete 12 hours. So in 1 hour, it will complete, in 1 hour, the minute hand from here, the hour hand, when it goes from 2 to 3, it will make 30 degrees. And in 1 minute, it will make half degrees. So angle described by the hour hand in 1 hour is equal to 30 degrees, and in 1 minute is equal to half degrees. And angle described by the minute hand in 1 minute is equal to 6. So for minute hand, the long hand, it is 6 degrees, and the short hand, the hour hand, it is for 1 minute, it is half degrees. So you can remember 6 and half. Area of a sector. So the sector is the area, the region bounded by the two radii and the arc. And this arc, the endpoints of the arc will be the endpoints of the radii. So AB. So this portion is called the area of the, this is called the sector, and this is called the area, and just we have to find this length, means that is called arc length. AB is called arc length L. So 360 degrees, the full circle, the circumference is 2 pi r. So we have to find the arc length of this AB, a part of the circle. So theta is equal to, where the angle is theta degrees. So the full circle 360 degrees it is 2 pi r. For theta degrees, it is 2 pi r by 360 into theta, or you can even write this as theta by 360 into 2 pi r. So L is equal to 2 and 360 you can cut. So theta by 180 into pi r. Either you can use this or you can use this also, formula also. But this is very easy to remember, theta by 360 into 2 pi r. 2 pi r is a circumference. And so, and arc length is denoted by L. Now coming to area of the sector. For similarly the same thing will apply here. For full 360 degrees, the area of the circle will be pi r squared. So the area for this sector, where the angle is theta, is equal to pi r squared by 360 into theta. So rearranging this, you get it like this. So theta by 180 into pi r, we saw it is L. So you can substitute as half into L into r. So you can use both the formulas, theta by 360 into pi r squared or half into L into r, depending on whatever the data is given. The minute hand of a clock is 10 centimeters long. Find the area of the face of the clock described by the minute hand between 9 am and 9:35 am. That means it is moved from 9:35 minutes. So, angle described by the minute hand in 1 minute is equal to 6 degrees. So, at 35 minutes, the angle described by the minute hand will be into 35, 6 into 35, that is equal to 210. R is given, the minute hand of a clock is 10 centimeters. So, you have to take that as R. So, area is equal to pi r squared by 360 into theta. Substituting these values, theta as 210 and R as 10, 22 by 7. So, you get 183.3 centimeters squared. A pendulum swings through an angle of 30 degrees and describes an arc of 8.8 centimeter in length. Find the length of the pendulum. So, the pendulum swings through an angle of 30 degrees. So, this angle is 30 degrees. So, this is a pendulum. It moves like this. So, this is the describes an arc of 8.8 centimeters. So, this length AB is 8.8 centimeters. And so, from here it comes and then go back, oscillates. And this angle that it describes is 30 degrees. Find the length of the pendulum. So, now we have to find this length, or you can say this length. So, theta is equal to 360. Here arc length L is equal to 8.8 is given. Now, substitute in the formula. L is equal to theta by 360 into 2 pi r. You have L, you have theta, from which you can get the value of r. So, radius equal to 16.8 centimeters. The short and long hands of a clock are 4 centimeter and 6 centimeters long respectively. Find the sum of the distances travelled by the tips in 2 days. So, we have to find the arc length. It's not the arc, here they have not given you any angles. Here you have to find, it is covering, it is covering the whole circle. So, you have to find the total distance covered. So, here in shorthand, it is moving, both the short and long hands is moving for 2 days. So, the short hand in 1 day, it will rotate 24 hours. So, it will go around 2 times. So, in 2 days, it will go around 4 times, 4 rounds. So, distance is equal to, so 1 round is equal to 2 pi r circumference of the circle. So, 4 into 2 pi r. So, you get this. Now, coming to the long hand. In long hand, in 12 hours, the long hand moves 12 rounds. Because in 1 hour, it will move 1 circle. So, in 12 hours, 12 rounds. Now, we have 48 hours. So, it will move 48 rounds. Now, you have to find the distance. Again, 48 into circumference, 2 pi r. And r is 6 centimeters, because the long hand is 6 centimeters. And you get this answer, and you add the sum of the distances, you get 1910.85 centimeters.